Today we discuss about two circuit diagram. One is digital to analog converter and analog to digital converter. So first we discuss what is digital to analog converter. It is also named as DAC and it is also named as ADC. Okay, digital to analog converter and analog to digital converter. First of all, digital to analog converter is basically designed using operational amplifier, and ADC is designed by using resistor or counter, and there is current to voltage converter, I to V converter, and one comparator are used. Okay, first of all we discuss about what is digital to analog converter. Digital to analog, our first topic. So the circuit diagram is look like here, or one op amp is connected. We consider 4 input, okay, because 4-bit binary combination, that's why we here connected 4 resistance, and these for the closed loop gain, one feedback resistance is connected known as RF, and non-inverting terminal is grounded, and these output voltage V0. And now here we apply our binary B input, say V3 Vi. V3 means binary bit V3, V2 Vi, V1 Vi, and V0 Vi. Okay, and the resistance are R0. Say the value of resistance, say first of all this is R0, okay, and next this is R0 by 2, this is R0 by 4, and this is R0 by 8. So there are basically 4 current, I1, I2, I3 and I4, or also known as I1, I2, I3, I4. This 4 current is addition at the terminal A. So applying KCL, if we applying KCL, and here the current equal to say IF, feedback current. Now if we applying KCL, then what is the total current at the point A? So at point A, the for current is I1 plus I2 plus I3 plus I4 is equals to sum of the entering current equal to sum of the leaving current, that is IF is the leaving current. So what is the value of I1? So I1 first this value of current, that means this voltage V0 into Vi minus 0. Why this is 0? Because due to virtual ground this potential equal to 0 volt divided by R0. Okay, next one V1 into Vi minus 0 divided by R0 by 2, because this is R0 by 2. Okay, next one is V2 into Vi minus 0 divided by R0 by 4, and last one V3 into Vi minus 0 divided by R0 by 8 is equals to 0 minus V0 divided by RF. Okay, this is 0 volt minus V0 volt. Okay, now simplicity of this mathematical expression, simplify this. So this is V0 Vi by R0, this is V1 Vi into 2 by R0. Okay, and this is 4 V2 into Vi by R0 again, and this is 8 into V3 Vi by R0 again, and this is minus V0 by RF. So what is the value of V0? What is the value of Vf? So Vf is basically minus RF by R0. Okay, so and we take the common part, Vi is a common. Now what is our value of the input? So first of all we write here 2 to the power 3, that is this input, 2 to the power 3 into V3, because 8 becomes another expression by 2 to the power 3, 4 becomes the another expression of 2 to the power 2, 2 is another expression expressed by 2 to the power 1, and 1 is 2 to the power 0 into V0 here. This is a V0 here. So this is the output expression of this digital to analog converter. Here Vf is the feedback voltage, is the output voltage basically. So just a minute, this is not a Vf, this is a V0, extremely sorry, this is a V0. Okay, this is output voltage, at the operation amplifier output. So 4 digital input apply here. So the corresponding, depending on the corresponding input, the output is produce the analog voltage. Okay. Okay, now we put this binary number in a table form, and first of all consider RF equal to R0, and the formula is these are another mathematical expression, because if RF equal to R0, the gain equal to 1, so V output equals to just V input into other these binary combinations. Okay, so now we form on a table B3, B2, B1, B0, and look the status of the output voltage. Okay, so what is output voltage? So there are basically 16 combinations are possible for 4 input binary. This is 0010, this is 0011. Okay, this is 0100, this is 0101, this is 0110. Sorry, 0 is here in the lower bit, then again 0111, then again 1000, then 1001, then 1010, 1011, and next 1100, 1101, 1110, and last combination is 1111. So for all possible input combination, what is output voltage? So first, if all input equal to 0, that is here 2 to the power 3 into B3 plus 2 to the power 2 into B2 plus 2 to the power 1 into B1 plus 2 to the power 0 into B0. Okay, so if all bit equal to 0, that is this equal to 0, 0 and 0 and 0, then total combination equal to 0, then 0 into V input, output equal to 0 volt, that is 0.00 volt. So this is in a form of volt. Okay, and when 0001, so what is the input voltage? This is minus V input, because this value equal to 1. What is this value? This is minus 2 V input, this is minus 3 V input, this is minus 4 V input, and so on. This is minus 5 V input, this is minus 6 V input, and this is minus 7 V input, and this is minus 8 V input, and this is minus 9 V input, this is minus 10 V input, this is minus 11 V input, and ultimately the final combination is minus 15 V input. But here the problem arises, because this magnitude of this input voltage equal to 5 volt, because this input voltage equal to 5 volt, because digital input equal to either low or high. If low, then input equal to 00, if high, then this is 5 volt. And here look here, that 15 into 5, that is minus 75 volt arises across the operation amplifier. Is it practically possible? No, because operation amplifier biases by either plus 12 volt to minus 12 volt or minus 15 volt to plus 15 volt, anyone. So maximum possible output is plus 12 volt. So what are the suggestions? Now the suggestion is that this RF not equals to R0. For mathematical simplicity, we take here RF equal to R0, but in practical senses, this RF should be 3 times of R0. Okay, so now what is the changing in formula? The changing is that here RF equal to 3, that means here RF by R0. Okay, and this is the okay, not RF, just we consider here, not RF is the 3 times of R0, just we consider here R0 equal to 1K. Okay, and RF equal to 10K. Okay, RF 10K, and this is sorry, this is R0 equal to this R0 value and RF value, 2 values are arises. So now R0 value equal to 10K, and this is 1K. So now if we consider this value, then what is the gain? The gain is 1 by 10. So every voltage by 10. Okay, so that because here we see that RF equal to 1K, so put here 1K, and R0 equal to 10K, so put here 10, so 1 by 10. So basically this input voltage by 10. So now here the possible outcomes are 3 V input by 10. So this is practically possible, because 70, this is, if V input equal to 5 volt, then 15 into 5, 75 by 10, that is minus 7.5. So minus 7.5 is a permissible voltage, because it is between the plus 12 to minus 12 or 0 to minus 12. So this is the analog output. This is analog voltage output. Okay. So what is actual output? If V input equal to 5 volt, then this value equals to, what is the value of this? Actual value is minus 0.50 volt. What is the value actually? Minus 1 volt. What is actual value? Minus 1.5 volt. This is minus 2 volt, and so on. And ultimately the final voltage equals to minus 7.5 volt. So now you see that the corresponding digital input, I again repeat, the corresponding digital input produce the corresponding analog value output at the output of the reverse amplifier, and that's why this circuit is named as digital to analog converter. So this is our first circuit today in this class, how operate the digital to analog converter and how digital information comes here and to produce the analog values, because these are very important for any communication system where digital data is converted to the analog data to get a audio sound or any kind of information can be shared by using two communication media. When digital data present in the receiver, then we must be converted it to analog, because all data finally getting in analog front end for the analog voltage. So this analog voltage produces the output, so that's why this circuit is named as digital to analog converter. Okay, now we discuss about the graphical representation of this circuit. So in a x-axis we represent the binary combination, that is here 0000, here 0001, and this is considered 0010, and so on. Ultimately the last voltage is, the last input equals to 111, all are equal to 111, 4 bit. Now here we mapping for 000, what is the voltage at the output? 0. That means here we put here the value equal to V0. What is 00? That is the value of, it is not equal to 0 because this is minus 0.50. So basically this is not in this direction, this is basically in a minus. That is the voltage in a negative, that is the voltage in a negative output voltage. Okay, because it's the inverting amplifier, and next one is higher, then next one is higher, and so on. And now if we connect all the voltage, it's look like a staircase. Okay, stair. Okay, it's a staircase. So now follow these different types of voltage, ultimate it goes to minus 7.5, and this is, just consider this is minus 7.5. okay, because 7.5 is where when input equals to 111. So this is the input versus this is a here we present our, in x-axis we plot our binary input. Okay, and in the output axis we plot the output voltage, and here we plot the output voltage. Okay, so now here the graphical representation of this digital to analog converter.